Yeah.
Cool.
All right. Hello, everybody. We are members of the SUCS Capstone 2021, and our Research and Creative Works project, or capstone project that we're presenting here, was the Southwestern University Greenhouse Monitoring System. And the contributors included Taylor Carney, Tim Fields, and Joe Roybal, who worked on the back end, and Kirby Steckel and myself, Colt Smith, who worked on the front end. Next slide.
The Southwestern Greenhouse monitoring system is a responsive dynamic website that allows the members of the SU Garden Club to keep real-time records of the many plants and variables within the SU greenhouse. We decided that we liked this project because of the many aspects that it covers. The fact that there's a hardware component was very interesting to us, which grasp our interest. It's also a much easier way to keep track of what's planted in the greenhouse than using something like a spreadsheet. Next slide. Here are some pictures of the greenhouse. In the bottom left is a picture of the front of the greenhouse. In the bottom middle is a picture of the back of the greenhouse where the outer garden is. And on the bottom right is a picture of one of the beds within the greenhouse there are 12 of them total. Next slide.
Awesome. Hello, I'm Joe Roybal, and I primarily worked on the back end. So some of the tools that we used were HTML, CSS, and JavaScript, which were used to develop the front end. These are things like font, formatting, spacing, everything that the end user will be seeing on the website, how it looks. And then the back end, which is my wheelhouse, we primarily developed in Python. This was chosen both for our familiarity and also because it was believed that this would have fewer compatibility issues when integrating our Raspberry Pi into the monitoring system. So now that we had our language determined, which was Python, we needed to find a framework to use. We chose Flask because it is a micro framework, which means that it is a little bit more lightweight and quicker than a regular framework. And this would be used to make our Flask application. And in order for our Flask application to communicate with our database, we needed to have a Flask SQLAlchemy plugin. And this was a way of creating and communicating with the PostgreSQL database that was being hosted on Heroku. And Heroku is a platform as a service, or a PaaS, that allows developers like us to build, run, and operate applications all from the cloud. So our the entire code base that we had, front end and back end, is on GitHub, and then Heroku would make a request to GitHub to retrieve that information and then display it on the domain that we have, which is sugarden.club. Next slide.
Hi, I'm Taylor Carney, and I worked primarily on the back-end development of our website. So originally, our group planned on using the incremental waterfall model to track our design process. However, our work was more accurately reflected in the waterfall with feedback model. The image shown is an example of the waterfall with feedback process model. In our project, we encountered a lot of forward and backward progress over the course of the semester, and this model has been a huge advantage in tracking our development because it allowed us to revert to a previous step in the event of an error. Our project has been through multiple setbacks throughout the semester, but with this model tracking and providing feedback for each step, we were able to overcome those setbacks to create a functioning website. Next slide. So how to use our website. First, the user will click on the bed that is to be updated. Next, they will check the current contents of that bed, or they will click on the update form button. Next, they will log in using the Garden Club username and password to access the form, and then they would fill in the empty fields on that form. And finally, they would click the Plant It button to update the form. And more details about how to use our website will be in our brief demonstration towards the end of the presentation. Next slide.
So I'm Tim, and I kind of split my time in between the back end and the hardware aspect of this project. So I was working a lot with the Raspberry Pi and as well as with Joe and Taylor to get all of that stuff to sync together and work. But some of the features that are included in this application and monitoring software are there are fields to track when something was planted as well as its germination date, which for those of y'all that don't know that, we all had to go look that up. And a brief definition of the germination date is the date that the seed either sprouts or fruits, basically when it goes from being a seed to an actual plant. And it's definitely something that they want to keep track of. So we made them a field in the database to be able to keep track of that. And then also the date last watered, as well as the current soil moisture percentage, so that not everything in there works perfectly, and a lot of it is manual. So the date last watered is a bit of redundancy to monitoring the soil moisture as well, so that they can make sure that like the sensors will eventually probably start to have issues at some point down the road. And they see that the last time it was watered was 3 weeks ago or something, but it's still showing 90% soil moisture, it might be time to change out that sensor before something bad happens to the plant. So we've got that in there as well. And then with all of the soil moisture sensors, we also have a temperature and humidity sensor so that they can monitor what the actual, basically all of the conditions for growing the plants inside the greenhouse are. And they have their own climate control system in there that will manage all of that, but there's no really easy way for them to read it without actually going to the garden, the greenhouse itself. So this just basically put everything that they needed in a nice, easy to use format on our web application. And then as for the hardware aspect, this is part of the development process here that you're seeing. What's actually going in the greenhouse will be looking much nicer. There won't be a breadboard, which is what this is here on the left. They're often used for all sorts of computer hardware prototyping, and it's basically just a big electrical grid that you can put things through to test it. So we use this as the breakout from the input-output pins on the Raspberry Pi, and then this goes through an analog to digital converter to get the actual information from the sensors. We were hoping to keep it a little simpler than that, but unfortunately the first set of sensors, like Taylor said, there was a lot of trial and error involved in this process, and the first digital sensors that we got, they just didn't work. So we had to get these ones that are objectively much better sensors, but they were more difficult to wire up because Raspberry Pi won't accept analog signals. So we had to do digital converter and then write up some Python code to be able to handle that. And that's basically what you're seeing right here. But it will all go soldered onto a very small PCB and be a lot more discreet and less of a spaghetti wiring disaster than what you guys see here. And then these are some examples of our sensors. We tried to keep the costs on everything really low. So these are like $1.50 or something from Amazon, and they should last for a very long time. And then this is basically just the basic tools that were used on the hardware is the breadboard over here on the right, and then these jumper wires for the prototyping, as well as a picture of the Raspberry Pi that's going in the greenhouse right there.
All right, so now we are going to watch a pre-recorded demo that I created. Just a quick disclaimer. There are, in the demo, we did not have the soil monitoring sensors set up quite yet. So the fields for soil moisture and temperature are going to be a static and inaccurate number in this particular demo. But by the time the website is completely finished, we will have that information set on there. So just a heads up. All right, Tim, you can start the video. So to start off, we're going to go to sugarden.club, which is the domain name that Joe was talking about. This is our homepage. There's this nice About Us section and a few images of the greenhouse and some of the plants that they work with. And there's a little nifty animation for when you hover over those pictures. When you enter the front room, you can click on one of the beds. So I chose bed 106. And we see that there's nothing planted, so I'm going to log in with our username, SU Garden Club, and a super secret password that I'm not telling you. So we can just wait for me to type this out. Wonderful. So the user can enter their name, they can enter the plant species, and then the germination date. So I'm going to be planting potatoes, and you'll see a brief hesitation when I enter the germination date because I did not know what germination meant when I was creating this. So I just kind of guessed that meant time when it grew. So I said for April 15th, 2021. And then I said that potatoes grow in about a month, I guess. So I said I planted them on March 15th, 2021. And as you can see, the temperature, humidity, and soil moisture are all going to be static fields. And the bed number is also a static field. The form wouldn't work if we didn't have that field, but the website itself stores what bed number, not the database. And then I said I last ordered it on the date that I was filling it out. So I'm going to click on the planet button. Chrome is going to send a pop-up that says, thanks for putting potatoes in bed 106. And then when I go check bed 106, you'll see that the info is there. So that's kind of how the site works, and what the general user will go through to plant their items. All right, next slide. You can do it. How will this continue to work? So myself, Joe, Kirby, and Taylor will all be graduating this spring, but Taylor will be staying for another semester. So she will be the Garden Club's contact next semester, and she will do some site maintenance. This isn't a much, like, you don't really need much maintenance for the site. It's just every once in a while database purging that might need to happen. But other than that, it's a pretty straightforward site. And as for the Heroku and domain name, that is the property of the Greenhouse Club. They can use it as they choose to, and ask, any computer science, person who's left over after we leave, how to work with the domain name of Heroku. So that's it. Any questions?
I have a question.
Mm-hmm.
So I saw that, so y'all have like the Raspberry Pi and the breadboard, and I assume that's going to go in the greenhouse. How are you going to prevent from moisture and stuff from corrupting that? Do y'all have like a case or something?
Yes, so there's a lot of really cheap waterproof cases, but also we were just going to get a little conduit box that's meant for sealing up electrical and stuff. One of the really nice things about the Raspberry Pi is that they don't really make a whole lot of heat. So putting it in an enclosed space like that, and this one's also not doing anything particularly heavy as far as computing and stuff. So we'll be able to have that sealed up in a conduit box with all the wires running out of there. And there's also kind of a closet in the greenhouse. We didn't really have a picture of that, but there's a section there where they have all of their like HVAC controllers and stuff like that, because that was actually something that we were worried about. But then after we took a tour of the greenhouse, we were like, oh, we can just basically put it on the wall right here, and it will be nice and out of the way of everything that could potentially cause problems.
Awesome, thank you.
Do we just talk for a question?
Yeah, go for it.
Okay. I was curious about the soil moisture sensors. Do you stick that directly into the soil, or is there something else that goes in because it has all that electronics at the top?
No, actually, you just put them right in there. Let's see if I can jump back to picture.
That's what it looked like. Okay.
Yeah, so you pretty much just put them in up to this white line here. I don't know if you guys can see my mouse moving or not.
Can see it. I can see it.
Okay, so you pretty much just put it in right up to there, and these actually have some sort of, I believe whenever I was looking at them, they have some sort of like conformal coating on there that should keep them pretty safe. But
Okay.
Yeah, they're definitely designed to get a little bit wet.
Yeah.
I'm not sure if it'd work so well if you just dunk the whole sensor in a cup of water or something, which almost happened in testing a couple of times, but they still work. So they seem fairly robust.
All right. Well, thank you very much.
Yeah.
It's really cool.
Any other questions?
So I have a question, and it kind of goes to the entire group. After this project is finished, what was your greatest challenge looking back on the project itself? Was there one in particular?
I think each subgroup of our group has their own kind of like greatest challenge. Like for Kirby and I working on the front end, it was making the website responsive, getting it so that the images and everything, and responsiveness means basically that it shows up and looks good on a mobile phone or any screen size, really, that it looks good on any screen size. So getting everything to look good on a phone, especially because of some of the design choices we made early on, proved to be quite a challenge and required some reworking. But I don't know, the back end had different issues, and so did the hardware side.
Yeah, so for the back end, I would say probably the biggest issue I struggled with was that we haven't really ever done anything like this. And so it was both a struggle and also quite fun to figure out how it all works. Of course, now knowing what I do know, I believe I could do this faster than I had before because I would be able to circumvent a lot of errors I made. So, yeah.
Yeah, and to kind of build off that, I think another challenge we had was like using Heroku, because none of us had ever used that before. And that actually came from another capstone classmate who recommended we use that. And so there was a lot of time where we weren't exactly coding. We were more like researching how to code in Heroku or how to use Heroku, because we just didn't know. But it was a really fun learning experience. And I'm glad that we got to use it. And I think I could use it again.
Just a quick one for probably the most difficult thing on the back end was once I realized that the sensors that I wanted to use weren't going to work, having to switch over to an analog to digital converter and write all of the code for that was definitely a major speed bump in that. But I think if I can speak for most of the group, I think one of our single greatest challenges was merge conflicts on GitHub, having front end working on their stuff in the back end. I know Joe and Kirby spent a lot of time on multiple occasions sorting all of that stuff out. I don't know if they can speak to that anymore, but yeah.
Yeah, no, it was just little things that got caught up whenever we merged. It wasn't which is the unfortunate part. It wasn't necessarily anything major. It was a bunch of minor mistakes that added up to a very time-consuming task of figuring out how to reformat how this file was structured or how it was called, and just making those little edits as we went.
Yeah, it pretty much boiled down to like 1 or 2 lines that needed to be changed pretty much every time.
Well, thank